Biotic and abiotic factors. As far as we know, the one thing that Earth has and no other planet has is life, or also known as biotic factors. To start, biotic factors refer to the ones living organisms in an ecosystem. All of these are obtained from the biosphere and the ones that are able to reproduction. Examples of biotic factors include birds, plants, fungi, among other living things. The world is surrounded by biotic factors. However, there are also things named as abiotic factors. Abiotic factors refers to the non-living things in an ecosystem. Abiotic resources are obtained from the lithosphere, atmosphere, and hydrosphere. Examples of abiotic factors include water, air, soil, sunlight, and minerals. Biotic and abiotic factors have more to do in how these parts affect an ecosystem than the specific living or non-living. Competition, consumption, parasites, disease, and even symbiosis are always how it might affect the ecosystem. An example could be a consumer like a giraffe eating plants. A living thing affects another living thing. Heterogeneous and homogeneous mixtures. The terms homogeneous and heterogeneous refers to the mixtures of materials in chemistry. The difference between homogeneous mixtures and heterogeneous mixtures is the degree in which two or more materials are mixed together and their composition. A homogeneous mixture is a mixture where the components making up the mixture are distributed evenly throughout. Examples of homogeneous mixtures are air, vinegar, and dishwashing detergent. Only one type of matter is present on this mixture, meaning you can separate these materials used in homogeneous mixtures. A heterogeneous mixture is a mixture that the components making up the mixture are not distributed evenly. Different properties of the mixture are not identical to each other. There are always two to more phases in a heterogeneous mixture. Examples of heterogeneous mixtures are cereal in milk, pizza, colored candies, and many others. Mostly, the difference between homogeneous and heterogeneous mixtures is a matter of scale. If you look closely at sand from a beach, you can see the different objects found in it, such as shells, coral, sand, and organic matter. Because of this information, we can tell it's a heterogeneous mixture. How can you tell a homogeneous mixture from a heterogeneous mixture? To identify the mixture, consider the sample size. If you can see one or more substances of matter or different regions, it is a heterogeneous mixture. But if you can't tell the different substances used, it is a mixture called homogeneous. So now that you know what a homogeneous and heterogeneous mixture is, can you tell which of these two substances is homogeneous or heterogeneous? The scientific method is a process for experimentation. It is used to explore observations and answer questions you have. The goal of the scientific method is to discover the cause and effect relationship by asking questions, examining and gathering information to find a logical answer. The scientific method will help you answer your questions as well as possible. The scientific method consists of 6 different steps used. The first step of the scientific method is the purpose, which is the purpose of the experiment. Why are you doing it? What do you want to learn? Then, the research. In the research, you find out more about your experiment. Look for articles containing your topic in order to have more knowledge about what you're doing. Next is a hypothesis. The hypothesis is a prediction of what your experiment is going to turn out to be. Your hypothesis should go something like this. If I do this, then this will happen. Next is experiment. You have to design a test in order to confirm or disprove your hypothesis. In your experiment, you should include materials and procedure. Then the analysis. In the analysis, you should record what happened during the experiment. All your notations about what happened should be written in your analysis. And finally, your conclusion. In your conclusion, you should write if your hypothesis was wrong or correct. You write down what you found out about the experiment and what you thought about it. So you now know the different steps of the scientific method. Do you know what they stand for? So now, how does this relate to our everyday life? All of these topics can be found in real-life events. For example, biotic and abiotic factors, you can see them on a daily basis, since Earth are made by both. Homogeneous and heterogeneous mixtures can help you find out if you can separate your mixture or you can't. So for example, if you're doing a smoothie and you put strawberries and milk together but haven't yet blended it, you can still separate it, meaning your mixture is heterogeneous. And finally, the scientific method that will help you uncover any questions you have about any experiment if you follow the right procedure.